Problem 2. We want to figure out the direction of the induced current indicated in each of those situations shown here and labeled confusingly not in alphabetical order. Alright, this first one labeled C. We want the direction of the current in the solenoid, so that's this thing over here, as this magnet moves away from the solenoid. So step 1, what direction is the magnetic field? Now in this case it's the magnet making the magnetic field. Magnetic fields point away from north poles, so the magnetic field should point generally to the right through that solenoid. Now, is this magnetic field getting bigger or smaller? Well, this magnet is moving away from the solenoid, so that means the magnetic field should be getting smaller, thus the flux should be decreasing, which is case B we talked about. If the flux is decreasing, the induced magnetic field should be to the same direction as the magnetic field in the first place, so also to the right. So the induced magnetic field in the solenoid should be in that direction, to the right. Now, what direction is the current flow? Well, if it's going to make that induced magnetic field to the right, let's see, my thumb is to the right, my fingers curl up in the back, around and then down in the front. So in these visible portions of the wire, the current should be flowing down in the front, which should lead it down through there, right to left through the resistor, and then back up. Part A. We want the direction of the induced current in the solenoid again, and this resistance here as the magnet gets closer to the solenoid. So step 1, what direction is magnetic field? Again, here's N, so the magnetic field should be away from the N. Point, in this case, to the left. Then, is the flux getting bigger or smaller? Well, as this magnet gets closer, the magnetic field, here should get bigger as the magnet gets closer. So the flux should be increasing, which was case A. The induced magnetic field should be opposite in direction to the original, which would make it to the right. So the induced magnetic field produced by the current in the solenoid should be to the right. Again, if I point my thumb to the right, my fingers curl up in the back, out and down in the front. So these pieces of wire in the front of the solenoid should have current flowing down. And then over here, this wire comes down and then around through the resistance and back up the other side. So right to left through that resistance. Now, part B. Again, we want the direction of the induced current in this solenoid as the magnet gets closer, which looks exactly the same as the one we just did, except if you look closely, this wire is wrapped slightly differently. So the magnetic field again points away from the N. So the magnetic field from the magnet is to the left. Magnet's getting closer, so the flux increases, which is case A. The induced magnetic field will therefore be opposite to the left, which is to the right. And all of this is exactly the same as the one we just did, except that when we do the right-hand rule, magnetic field to the right, my fingers curl again out the top and down in the front. The wire is wrapped so that when it flows down in front of this solenoid, it flows down the left side and then the other way through the resistor. Alright, the last part, D here. What's the direction of the current induced in the thicker single ring? So that's this ring here, which is around the solenoid when the switch here is closed. Alright, so what direction is the magnetic field? Well, I guess initially there isn't any, but when this switch is closed, see here's the positive terminal, current should flow up that way and then down around these wires and then back to the battery. So if that current is curling around this way, my thumb is pointing to the right, magnetic field produced by that current should be to the right. Now, is the flux increasing or decreasing? Well, initially we've got nothing. We close the switch, current flows, and then we have something. So the flux is increasing, which is case A. So the induced magnetic field should be the opposite direction, which in this case would make it to the left. So if the magnetic field is to the left, thumb to the left, my fingers curl around up in the front and then around and down in the back. So in that particular little wire, this thick wire, the current should go up in the front and then down behind. Again, if you draw the arrows right on the figure, that might be a little bit easier to see.